All right, let's look at this problem. It's a little more complicated than the ones we've done before, but the general set of rules is going to be the same. We've got a laser pointer here, and it's like on a record player or something spinning around. And so the dot is going to put a dot on the wall, and the dot's going to move up the wall. Well, I say up the wall. It's going to move across the wall. The view we have here is like top down. But it tells us that the laser pointer is spinning at 10 revolutions per minute. And it asks, how fast is the dot moving when the angle made with the wall is 60 degrees? And it says, give your answer in feet per second. Now, there's several things we have to do here, because this is saying feet per second. This is revolutions per minute. And this also says it has to be the note says we have to convert everything into radians in order to make all of the units work out correctly. So let's label this. This is our angle. I'm going to call that theta. And what we've got here is a triangle. The distance across here is 6 feet. And this distance over here, that's what we're trying to find. How fast is the dot moving? We're trying to figure out how fast is this distance changing. Let's just call that distance b. So how can we relate theta and b? Well, if you look at this as a triangle, as a right triangle, we've got, relative to theta, we've got the opposite and the adjacent side. So what we can say is tan theta is opposite over adjacent, or b equals 6 tan theta. So that's our equation, and our rate equation is easy to find. dB dt, the derivative of tangent is secant squared theta. Then we have to multiply by d theta dt. So that's our rate equation. But on this one, we've got to work out what the rates are that we're given. So that we're given in that we're asked for. Notice they ask, how fast is the dot moving when the angle is 60 degrees? So what they're asking us here is to find dB dt when theta is 60 degrees, or pi over 3 radians. We have to convert all these angles to radians to make this work out right. And so we also need to know, what is this d theta dt? Well, we've got to come up with that from this 10 RPM. So d theta dt. I'm going to bring that over here to do it because it's going to be slightly long. So d theta dt, that angle is changing at a rate of 10 RPM, or revolutions per minute. Now, they want the answer in feet per second. So we need to convert this from revolutions into radians, and we need to change the time from minutes into seconds. So I'm going to do that with my dimensional analysis here. Let's see, 10 revolutions per minute. Well, we know that there is 1 minute in 60 seconds, or 1 minute is equal to 60 seconds. So I can multiply by that. And so that gives me revolutions per second. Now I need to change this into radians per second. So on the circle, a full revolution of the circle is 2 pi radians. So 1 revolution is 2 pi radians. Now I could put radian out there if I wanted to, and I guess I'll do that. So the revolutions cancel, and I'm left with, if you look at the units that are left there, it's radians on top and seconds on bottom. So let's see, this will give me 2. If I multiply across, I get 20 pi radians per 60 seconds. And if I reduce that, it turns into pi over 3 radians per second. So that's my value I need for d theta dt. So now all I need to do is take this and plug these into here, and it'll give me the answer I want. So plugging into this, dB dt is equal to 6 secant squared pi over 3 times d theta dt times pi over 3. All right, let's see. So that's 6. What's the secant of pi over 3? Well, let's see. Cosine of pi over 3 is 1/2. So secant of pi over 3 is 2. So I get 6 times 4 is 24 over 3 is 8. So I get an answer of 8 pi feet per second. All right, so 8 pi feet per second. If you think about it, I think that makes good sense. That's when this angle here is 60 degrees. When the angle gets bigger, the dot's going to be moving faster because if you're pointing the laser at the line, when it's hitting the line here, if you think about this as if you were like next to a big building with a laser pointer. When you're pointing the laser at it up close to you and moving the laser, it's not going to move very fast. But if you point it at a really big angle where you're shooting the building really far off, it's going to move a long distance when you just do a small arc. So if we were to do this again, instead of using 60 degrees, if we used something that was bigger, like 80 degrees or getting up close to 90 degrees, that speed's going to be huge. But anyway, this is the answer for when theta is 60 degrees. These are pretty long problems, so I'm going to do one per video.